As always, in this edition of The Plain Facts, we slice up the history of aeronautic development into bite-sized chunks. This time, we will show you how huge pieces of cargo, like the Saturn rocket motors for NASA, were transported, and how today's commercial aircraft developed from the lessons learned from World War II bomber advancement. Then we'll have an accelerated look at the amazing baby F-5 from Northrop and its stunning comparisons to the Tomcat and Viper. All this and more in The Plain Facts. Guppies were designed for the single job of transporting the Apollo rocket stages from California to Florida. Apart from flying the rockets, the only other option was a slow boat through the Panama Canal. The Guppy cut months out of the Apollo schedules, and without them, a moon landing in 1969 would have not been remotely possible. The Guppies have a most interesting way of being loaded. They are actually split in two. The cargo is then brought on, and the two sections of the aircraft are rejoined. A later version of this craft was called the Super Guppy. The cargo section diameter was increased from the pregnant Guppy's 19-foot to 25-foot, and the fuselage was also stretched by 26 foot. The splitting of the plane's hull was a major operation and was only suitable for the transportation of specific items, such as booster rockets. The plane manufacturer Airbus also needed the Super Guppies to transport plane components from various factories to the final assembly plants. With the rapid growth of Airbus, the Guppies eventually arrived at the limit of their capacity. The planes were aging and consequently maintenance costs were rising. So Airbus decided to construct a new and better plane. And this is what they built, the Beluga. It has a main deck cargo volume greater than the Lockheed Galaxy, the Antonov AN-124 and the American C-17 military cargo planes. The Beluga can carry up to 1,500 cubic meters of volumetric freight over a range of 1,660 kilometers. Recently, a Beluga accomplished the longest charter flight ever, 25 hours of flying including stops. The journey took the Beluga from Marseille, France to the Avalon Air Show in Melbourne, Australia. The mission was to transport 3 helicopters for Eurocopter. The white whales transport cockpits, fuselage sections, wings and tail units to the final assembly centres of Airbus in Hamburg and Toulouse. Airbus is the only aircraft manufacturer to use air transport as the main link in its production cycle. At the current levels of production, the fleet is performing more than 40 ferry flights a week between Airbus sites. Some of the parts that are flown by the Beluga include the 42-ton wing parts of the A330-340 wide bodies and the rear fuselage section of the A300-600 airline version. This section's size is 4.6 metres in diameter and 22 metres long. Beluga carries these massive units in one complete piece. In order to achieve necessary freight volume, the upper fuselage of a standard Airbus was severed at floor height and replaced by the characteristic and bulkier horseshoe structure. In order to make the loading and unloading as simple as possible, the cockpit was placed below floor level. The plane's giant loading hatch is approximately 100 square metres and 17.3 metres high when opened, or about the same height as a 5-storey building. The diameter of the fuselage that can be used for cargo is 7.4 metres, and the floor width is 5.43 metres. The length of the freight space is 37.7 metres. To improve the Beluga's stability around the pitch and yaw axis, the horizontal tail was strengthened, and the vertical tail was placed higher than on a conventional aircraft. Stabilisers were added to the tail unit to improve the rudder's effectiveness. Compared with the Super Guppies, the A300-600 ST, Beluga offers an increase of all-round 30% in cargo volume and double the payload of 24.1 tonnes to 45.5 tonnes. On average, it took a Guppy 54 hours to transport the bigger components. The Beluga manages the same task in just 19 hours. The Beluga's economical service saves Airbus about 2/3 in transportation costs. Built in 1922, the Barling was the first attempt at building a really large bomber and was designed from the ground up. The result was a triplane, which was powered by 6 420 horsepower Liberty 12A liquid-cooled engines. 4 of the engines were in tractor configuration, while 2 more engines were placed in a pushing arrangement. The main landing gear had an incredible 10 wheels, and the box-like tail had a horizontal biplane design, which had 4 separate rudders. Its performance was appalling. The Barling was not a success, and the sole Barling was scrapped in 1928. It was not until May of 1941 that a true modern bomber was finally flown. The XB-19 was an all-metal stressed skin-low winged monoplane with a retractable undercarriage. Its wingspan of 209 feet made it the largest American plane to be built. It remained so until 1946. The XB-19 project was top secret and no production was ever planned. The sole aim was seeing how far the state-of-the-art could be pushed. The end of World War II led to many cancelled bomber orders. So Boeing started converting military technologies into civilian applications. From the B-29 bomber came the Stratocruiser, which saw a rising public interest in intercontinental flights that were comfortable, safe and fast. Boeing met those demands with the 377 Stratocruiser. The plane was a double-decker design that could accommodate 81 passengers in the upper cabin and 14 in the lower-level bar and lounge, which was accessible by a spiral staircase. 28 sleeping berths were located in the forward cabin for long flights. Passengers experienced glamour on the Stratocruiser and were even treated to in-flight fashion shows on flights between Chicago and Minneapolis. Unfortunately, the Stratocruiser quickly lost popularity. The Pratt & Whitney engines were costly and temperamental and often caused delays. The glamorous design was no longer admired as sleeker planes began to dominate the skies. The Stratocruiser was the last piston engine plane to be retired from service, and apart from its size, it was mostly remembered for its first-class luxury. Finally, civilian aircraft were being developed with the sole purpose of moving people. Unlike the Stratocruiser, which had military beginnings, planes like the Boeing 707 was the first true breed of international people movers. These could seat 220 people and had a range of almost 4,000 miles. Other smaller examples, such as the 727, were designed for national flights. However, it was Boeing's huge gamble to build a plane that made international travel affordable that altered the face of international travel forever. The twin-engine A330 combines some of the lowest operating costs of any aircraft ever designed, with maximum flexibility for a wide range of route structures. The A330-300, which first entered service in early 1994, typically seats 335 passengers in 2 classes or 295 passengers in 3 classes, and has a range of up to 10,400 kilometres. Another of Airbus's innovations, which was developed in 1991, is the family concept, which includes the introduction of fly-by-wire on commercial jetliners and CCQ, or cross-crew qualification. In essence, this allows a single type qualification across a range of aircraft. This extends from the A318 to the A340. An A318 pilot can simply receive a few days training and can be certified to fly an A340-600. Airbus's design team were faced with a problem when concepting the A330. Airbus management really wanted 2 planes, one for shorter runs and another for very long-range work. They wanted to break into the 747's domain. The design team and engineers did something revolutionary. They created a plane that could be fitted with 2 or 4 engines with very little alteration. 2-engine aircraft are more economical on short or medium-range routes. However, international aviation law requires 4-engine planes for very long-range routes. The remarkable operating efficiency of the A330-A340 family is enhanced by the voluminous underfloor holds, which generates cargo revenue. The A330 and A340 can carry 60 to 100% more freight than competing aircraft. The unmatched economics of these planes mean that they can operate profitable cargo flights without a single passenger on board. The A340-600 is one of the latest additions to the A330-A340 family. It is the longest and quietest commercial jetliner to take to the skies. Rolls-Royce was chosen to provide the power plants. The Trent 500 made its first test-bed run ahead of schedule at Rolls-Royce in Derby. During the month of May 1999, it achieved 60,000 pound thrust. Airworthy clearances were received in December the following year. The operational ratings of 53,000 and 56,000 pound thrust are well within the engine's limit, and even allows margin for future expansion. The first production engine was delivered to Airbus in March 2000 and made its maiden flight 3 months later. Development engines completed more than 4,500 hours of running, which included operating in simulated extreme weather conditions. During takeoff, the engine sucks in over a ton of air per second and is squeezed up to 40 times atmospheric pressure. The blades of the Trent 500's 97.4-inch diameter fan are made from titanium and have a hollow centre, making them light yet extremely strong. At the engine's core, the fuel burns at approximately 2,000 degrees centigrade. Metals in this part of the engine start to melt at 1,300 degrees centigrade, so sophisticated cooling techniques are used. The Trent 500 can deliver an equal amount of power as about 1,000 family sedans. The development of the Northrop F5 began as far back as 1954, when a Northrop team toured Europe and Asia to examine the defence needs of NATO and CETO countries. The conclusion of the tour determined the need for a lightweight supersonic fighter that would be inexpensive to purchase, easy to maintain, and capable of operating from short runways and poor quality airfields. With this criteria, the Northrop designers came up with the original blueprints for what would be the F5. This baby fighter went from the drawing board to become one of the most successful export products of the US military aircraft industry. Although it didn't have the speed performance of some of its more costly contemporaries, it realized exactly the parameters it was designed for. Interestingly, the F5 was not widely used by the US Air Force. The original plan for the F5 was submitted to both the Air Force and the Navy. The Navy rejected the F5, and the Air Force also wasn't enthusiastic. It saw no need for a lightweight fighter. However, it did require a new trainer. Northrop decided to meet this requirement, which was formalised in 1955. Undaunted by the US military's rejection of its baby-sized fighter, which was 1/4 of the weight of the Phantom, the Northrop company decided to proceed with the development of the N156F as a private venture. At a time when everything was getting bigger, faster and more complicated, the little F5 was the opposite. The plane used the best technology in a solid airframe, but everything was kept as simple as possible. The two engines could be accessed or removed by taking off the lower part of the rear fuselage. They weighed only 585 pounds each and could be removed and refitted by human muscle alone. In fact, engine removal and replacement could be achieved in 20 minutes. Over 24% of the plane's surface consisted of easily removable panels that allowed fast access to all major components of the aircraft. The components were arranged to be only 1 deep to increase the speed of servicing or replacing modules or parts. Even the diagnostic testing equipment was portable. In a combat situation, this meant the plane would have less downtime than any Sonic jet fighter before it. The first flight for the F5 was during 1959, and it wasn't until 3 years later that Northrop would receive its first order. This occurred when the US decided that rather than sell aging planes to their allies, they would supply them with better aircraft. This aircraft was the F5. On August 9, 1962, the Model N156F was given the official designation of F5A, and the official name was Freedom Fighter. Northrop was also permitted by the US government to supply the Freedom Fighter under the terms of the Military Assistance Program and the Foreign Military Sales Program. A total of 1,871 F5s were built by Northrop. and a further 776 were built under license in Canada, Spain, Switzerland, Korea and Taiwan. The F-5 is still an important part of many foreign air forces. For many countries, this would be the first time that they had such sophisticated fighters. The toughness of the aircraft made it suitable for impoverished allies. This is an F-5, demonstrating its ability to use a very secondary type runway. No other fighter of its day could land on such a strip, or if it did, the practice would be seen as bordering on the very dangerous. The armament included two nose-mounted 20mm cannons. Again, the access for maintaining the guns was like the rest of the maintenance procedures of the plane. It was easy, and minimal training was required for a crew to be proficient in reloading or calibrating the sights. To add to the little fighter's punch, it would carry sidewinder missiles and a number of other types of free-fall bombs. What is remarkable is that when pitted in military games and facing off with the heavyweights of air combat, the F-5 fighter won 85% of the time. Join us again next time for more amazing insights into the aeronautic realm with the Plane Facts.